Hello everyone. I wanted to give a quick lesson to just talk about some patterns that arise when you're doing combinations, which can be tremendously useful when you're calculating probabilities using binomial distribution. So the first thing I want you to remember is that when we are doing a combination, let's call it nCr, the formula for this is going to be n factorial divided by n minus r factorial times r factorial. So the first pattern that arises is that, let's say that we have n choose 0. So if we were to plug this in, we're going to get n factorial divided by n minus 0 factorial times 0 factorial. Well, whenever we have 1 factorial, this is going to be equal to 1. If I have one object, how many ways can I select that one object, where order does not matter? Well, there's one. I select the one object. What about when we have 0 factorial? Well, this is also going to be equal to 1, and this is because if I have no objects, again, I only have one way I can select them. I select none of them. So in this case, this 0 factorial is going to go to 1. N minus 0 is going to be equal to n, so this is going to be n factorial over n factorial, which will equal to 1. So anytime, no matter what size n your factorial is, n choose 0 will always be equal to 1. Now let's look at the other side of things. What about if I had n choose n? So again, I'm going to plug this into my formula. This is going to be n factorial divided by n minus n factorial times n factorial. So in this case, our numerator is going to be n factorial, and then this n minus n will give us 0. Again, we'll have 0 factorial, which we said was equal to 1, so this term goes to 1. We're left in the denominator with just n factorial. N factorial over n factorial, again, gives us 1. So just like when I said I have 0 objects, how many ways can I select 0 objects, which would be 1, select none of them? How many ways, if I have n number of objects, can I select all of them? Just 1, select all of them. So the next thing we're going to look at is going to be n choose 1. So again, plugging it in, we have n factorial divided by n minus 1 factorial over 1 factorial. Now this one, we're going to use a slightly different rule, which is whenever we have a factorial, we can write this as n factorial equals n times n minus 1 times n minus 2, so on and so forth, down to 3 times 2 times 1. And one of the factors we have with a factorial is that we can always stop at any point and just take the factorial from then on, right? If I have 5 factorial, 5 times 4 times 3 times 2 times 1, I can set this as 5 times 4 factorial, because 4 factorial would be 4 times 3 times 2 times 1, right? So if I have something like this, 5 factorial equals 5 times 4 times 3 times 2 times 1. This is just equal to 4 factorial. So this means that my n factorial can be written as n times n minus 1 factorial. And this is going to be very important for this one. So we have n factorial in our denominator. N minus 1 factorial in our denominator. So I'm going to rewrite this n factorial as n times n minus 1 factorial. The n minus 1 factorials will cancel, and I'll be left with n. So if I have n number of objects, how many ways can I select just one of them? Well, n of them, right? I can select the first object, or I can select the second object, or I can select the third object, or the fourth, or the fifth, up to I can select the nth object. So I can select each of them one time, right? So if I'm selecting one object, I can select however many I have, that many ways. On the other side, if we have n choose n minus 1, we're going to again write this out. We have n factorial divided by n minus. Now, when we're writing our factorial, notice it's n minus r. Our r is n minus 1. So this becomes minus n, and then minus negative 1 means that we add 1. And then, of course, we put n minus 1 factorial for our r. Okay, so n minus n, these two cancel. We're left here with just 1 factorial, which we said is equal to 1. So again, we're left with n factorial divided by n minus 1 factorial. So we can do n times n minus 1 factorial divided by n minus 1 factorial, which is going to leave me with just n. And you might start to see a pattern that's arising. When we had n choose 0 or n, our endpoints, it was equal to 1. When we had n choose 1 or n minus 1, so our first point in, it was equal to n. And basically, this is how the pattern is going to go. When you have a combination, if you were to graph it out, mind you, this is not going to be to scale because what's going to happen is it's going to grow faster and faster as you go inward. But when you're at your very lowest ends, at 0, we're going to have, right, you're going to have some point to 1, and at n, we'll have 1. And then whenever we get to the first one in, we might do something like this. And then we go inward again. It's going to get bigger and bigger and bigger, but again, it's not going to be the scale, but it will be the same as going in that number of points. So what this means is, no matter what combinations you're looking at, right, we had n choose 0 equals n choose n choose 1 equals n choose n minus 1, n choose 2 equals n choose n minus 2, n choose 3 equals n choose n minus 3, and this will continue on until you get to the very middle. Now there's two possibilities when you get to the middle. Either if you have an even number of combinations, including 0, right? So for example, let's say n is 20. In this case, I would have an odd number because there's the 20 numbers 1 through 20, but you also have to count that 0 because you can get 0 outcomes. Because for our random variable x, whenever you're doing a binomial type problem, or rather a combination, you have that it is equal to either 0, 1, 2 through n. So when I say you have an even number, what I mean is that's including the 0. If you have an even number, your middle two numbers at the very middle will be the same. If you have an odd number, this is the one exception where you will have one that is unique because there's no other number that's the same as it. It'll be the highest combination, and each one you go down will go down by the exact same amount. So this pattern can actually help you, especially when you're doing binomial probabilities, because first of all, the outer two combinations are trivial. You don't even have to calculate them. But also, if, for example, if you know what n choose 3 is, you know what n choose n minus 3 is. If you know what n choose 4 is, you know what n choose n minus 4 is. And this will actually help you do our calculations much faster whenever you're doing something like a binomial probability. While we're talking about combinations, I also wanted to quickly show you a method you can use to calculate these if you don't have a tool like a calculator or computer to calculate them. Now, mind you, this will only work typically when you have values that are kind of closer to the extremes, but it will make it a lot easier to calculate rather than listing out every possible value. So to remind you again, if we have n choose r, this is just going to be n factorial over n minus r factorial. Whenever you have some n choose r, the way that I would solve this is whichever of your denominator factorials are larger, just write it into the next part, don't change it. And then list out your smaller factorial. So for example, if you have 4 factorial, just put 4 times 3 times 2, and you don't have to really include the 1 because it doesn't change anything. For your numerator, you want to write out your factorial until you get to the point of your larger factorial denominator. So let's do a quick example. Let's say that I have 10 choose 7. This means that I have 10 objects and I want to select 7 of them where order doesn't matter. So writing this out, I would get 10 factorial divided by 10 minus 7 factorial, 7 factorial. Now, 10 minus 7 factorial is just going to be 3 factorial. So 7 factorial is my larger factorial. So this is going to be 7 factorial. I'm not going to touch it. I'm going to write out the smaller one. So this is going to be 3 factorial, which is just 3 times 2 times 1. But again, the 1 really doesn't do anything, so I'm just going to leave it off. Now for the numerator, I'm going to write this factorial out until I get to 7 factorial. So this is going to be 10 times 9 times 8 times 7 factorial. And now the way that this makes it easier to calculate is because, first of all, my 7 factorials will cancel. And I'm just left with 10 times 9 times 8 divided by 3 times 2. And we can do some cancellation here. So for example, 3 will cancel with this 9 and leave me with 3, and 2 will cancel with this 8 and leave me with 4. So now I'm just left with 10 times 3 times 4, which is a lot easier to calculate, right? 10 times 3 is 30, 30 times 4 is 120. No calculator necessary. Thank you for watching. To continue learning, click the linked video here for the next lesson. If there's a topic you'd like me to cover, let me know in the comments. Don't forget to subscribe, and I'll see you in the next video.